Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hello and welcome to Physics with Beth and Beth. I'm Beth. Today we're going to start our very first video in AP Physics C, which is our calculus-based physics, and we're going to be doing the mechanics only, not the E and M piece. In this first round of curriculum. It's also equivalent to your first engineering physics course in college, the mechanics piece. Again, not that E&M, which is electricity and magnetism. I'm excited to introduce this curriculum today. Being an engineer myself, this is very near and dear to my heart, and I love the AP Physics C curriculum. So we're going to jump right in. The first thing we're going to do is we're going to look at graphing. And before I start that, I should tell you a little bit about this AP Physics C curriculum. If you have been in AP Physics 1 last year or in a previous year. AP Physics 1 is algebra based, so we're going to be introducing some calculus, the derivatives and integrals into this curriculum. The other thing that's going to change is you're going to see a lot of some of the same equations. You're going to see the same units. Not exactly the same, but most of them are the same in the units. But the problems are going to be a higher level of analytical ability. They're also going to be more multiple stepped problems and more steps to those problems. Not just multiple step, but more steps than you saw in AP Physics 1. And they're going to require a little bit more analytical thinking about those problems. But I know you've got this. I'm excited to start this curriculum, so let's get going. We're going to do a little graphing. Most of this is review from AP Physics 1, but it's really important to review this. Hang with, make sure you understand it, because the very next video, my colleague Beth is going to be introducing that derivative to you. And you really need a good base of this, how to graph motion, before you go into that video. So let's get started. We're going to talk about how to graph. I'm going to graph a position. I have a position time graph here. I have a velocity time graph, and I have an acceleration time graph. I'm going to be translating this position time graph into a velocity and into an acceleration. Now, one thing we're going to remember and review is that old junior high equation, rise over run. For my position time graph, rise is on the y-axis, which happens to be your change in displacement, and your run is time. Okay, we know that that change in position over change in time is equal to velocity. All right, so our slope on a position time, and this is the slope, our position time graph, the slope is velocity. Okay, then we look at our velocity time. Again, I'm going to do that rise over run for slope, and I'm going to go ahead and write slope here. On the side, that's going to be your change in velocity is on my rise, my y-axis, and on my run is my time. Well, the change in velocity over time is a rate, just like change in position over time, but that is actually equal to acceleration. These are vectors. They have both magnitude and direction. I'm going to go ahead and put an A here. I'm going to put a V here. They are magnitudes. They are vectors. They have both magnitude and direction. Your displacement has magnitude and direction. All right, so let's just get started. I'm going to go ahead and just throw in a graph that looks like this. All right, we have a curved line in the position time graph that's going to indicate that we have acceleration. Okay, it's not changing at a constant. Now, it's worth noting, just as a reminder, that if I were to have a straight line on this, and let's say this thing was just stuck at 5 meters and not moving, a straight line on a position time means it is at rest, which means that your velocity is equal to 0 because it's at rest. A straight line on a velocity time graph would indicate, remember your units are always going to be your clue, that's 5 meters per second. That means you are moving. If you have a horizontal line on, and I've been saying straight, but I meant horizontal, sorry about that. If you have a horizontal line on your velocity time graph, then that means that you are moving. It's not at rest, like in a position time. You're not stuck at 5 meters. You're moving 5 meters per second. Let those units be your clue. That means that you have constant velocity. And if you have constant velocity, it means your acceleration is equal to 0. So let's remember what those are. All right, just to review that. Now, the other thing is on a position time, And I'm going to draw this over on the side. I have a position time again. I have a diagonal straight line. That's going to indicate constant velocity, because remember, the slope of a position time is velocity. That's going to indicate a constant velocity, which again means your acceleration is 0. So we're going to just kind of remember all of those. Good little review here. All right, let's get started then. We're going to get started back to, I have this curved line on my position time. And I want to translate that for my velocity time and my acceleration time. What does that look like on these two graphs? There's going to be 3 rules, or 3 steps, we should say, in order to figure that out. First step is you're going to determine the direction of motion, which is also going to equal the direction of velocity. Remember, in physics, again a reminder, summer's been long, but that your negative and positive in physics is going to mean direction. A positive direction would be north or east. A negative direction would be south or west. So I'm going to look at this. First, you can tell by the slope. I have a positive slope, positive slope, positive slope. So I know that that means positive velocity because my slope for a position time is just velocity. You can also, if you get confused on, I get stressed out on tests and I get confused on the positive, negative slope, look at your numbers and that'll help too on your units. I'm going from 0 meters up here to 5 meters. If I were to draw that on a timeline and here's my 0 meters and here's my 5 meters, I'm going east. That's positive. So my velocity here is indeed positive, okay? So now if I want to translate that, the second thing you need to do, I've determined my direction, check, it's positive velocity, I got that. Second thing I need to do is determine if it's speeding up or slowing down. And we're going to do that by looking at the slope. All right, I have a really steep slope here. I have a less steep slope, and then I'm almost at rest up here. I'm almost at a horizontal line. That means I'm going really fast, and I'm slowing down to almost a stop. So I'm going to put over here, number 1, I've determined it's a positive velocity. That's a positive slope, plus I'm going from 0 to 5 meters on my timeline. On my meter line, sorry. Second, I'm going to determine if I'm speeding up or slowing down, and I am in fact slowing down. I have a steep slope, and then I'm going almost to a stop. Okay, and we have the saying in physics, as goes the slope, so goes the motion. If we had a steep slope, that means we were going fast, and then less fast, and then almost to a stop. So we're slowing down. The third thing is you're going to determine the direction of that acceleration. All right, well, easy peasy, we got this. All right, here's the rules. If you are, and this is such an important concept, you cannot minimize how important this is. Not only through AP Physics 1, but AP Physics C in mechanics. If you are slowing down, your velocity and acceleration are opposite signs, meaning opposite directions, because remember, sign is equivalent to direction in physics. Speeding up, your velocity and acceleration are the same signs. That means they could both be positive or they could both be negative. They could both be in the positive, east or north. They could also both be in the south or west directions, but they need to be same sign. Opposite sign, one would need to be positive, one would need to be negative of that velocity and acceleration. So I'm going to look at this. Am I slowing down or speeding up? Well, I'm looking at this. I know I have positive velocity. I know I'm slowing down. So that means my acceleration is going to be negative. Why? Because if you're slowing down, opposite signs. If you're speeding up, same signs. I am definitely slowing down, so acceleration is negative. So now all we do is finish with the graphs. All right, I know my velocity is positive. I know I'm slowing down. I started really fast, so I'm starting up here somewhere, and these won't have numbers in them. And then you're going to to 0, because I'm at horizontal right here, which means at rest. All right, I had fast velocity at 5, let's just say, make up a number, 5 meters per second. I'm at 3 meters per second, 2 meters per second, and I'm at 0. I'm definitely slowing down. Okay, that is positive velocity. I have a positive velocity because I'm in the positive section of this graph. Negative is down here. Okay, then the next thing is I said my acceleration was negative. Oh, this worked out because we said that the acceleration, the slope of a velocity time graph is acceleration. So this is acceleration. Oh, and that is a negative slope. That works out. So I'm going to have a straight line right here in my negative area of my graph. Now, why a straight horizontal line, I should say, is because we're not dealing with acceleration changing yet. So it's going to be constant. This indicates constant acceleration. Okay, perfect. Let's do another one. Let's do one where it looks like this. All right, we're starting up here at 5 meters. You know, we just make up a number. I just said 5 meters, but whatever. And we're going down to almost 0. All right, because the very first step I'm going to do is determine direction of motion. What's the direction of velocity? I'm looking at this slope. That's a negative slope, that's a negative slope, and then I'm going down here to rest. All right, this is a steep slope, so I have a really steep slope, and which means high velocity, and then I'm going to almost rest. Okay, so first thing, determine direction of motion. 5 meters all the way down to almost 0. And let me put that a little closer so we can really almost be at 0. So that means I'm going 5 meters almost to 0 meters. I start at 5, 4, 3, whatever, and I go down. Okay, well, I look at my my meter line. I keep saying timeline, my meter line. I'm going from 5 meters all the way to 0. That means I'm going west or south, however you want to call that. We'll call it west. And that means that my velocity is now negative because I'm going west. So my velocity is negative. I've determined the direction of the motion. Perfect. Step 1 done. Step 2, determine if you're speeding up or slowing down. I'm really steep, less steep, and almost at rest. So I am slowing down. Now I'm going to look at, okay, my velocity is negative and I'm slowing down. So the third step is determine your acceleration direction, which is going to be the sign. If you're slowing down, which I am, they need to be opposite signs. If velocity is negative, that means acceleration's got to be positive. Opposite signs. Now we're ready to do the graph. Here we go. We have a really high velocity and it's negative. So I have a really high velocity. Here's my negative. I need to be in this part of my velocity graph because it is negative. That's a negative slope. And we already determined I'm going from 5 to 0, so west direction. So I'm at a really high velocity in my negative area and I'm almost going to rest. So it looks like this. This is my rest at 0 meters per second, right here. And I'm at something high. Let's just make it up. I'm just making up numbers because these won't have numbers. Negative 5 meters per second, negative 4, negative 3. And you're like, but how are you slowing down? Okay, I'm slowing down because remember, this negative just indicates direction. I'm at 5 meters per second, then 4 meters per second, then 2 meters per second, and then 0. That negative is simply telling you I'm going west or south, depending on what the directions tell you. All right, now I have, look at this, I have a positive. Remember this, velocity is the slope. Remember on this one, acceleration, on a velocity time graph, acceleration is the slope we determined. All right, well that's a positive slope. And look, we said it should be positive. So it worked out perfect, and that's your positive acceleration. And it's gonna be constant there because we're not changing. Let's do one more and then we're done with this video. We have reviewed everything we need to review to get you ready for your derivatives. A thing to notice though, that all of these slopes are averages, okay? That's going to be very important because your derivative is going to be something different than that. So that's important to know that we're talking about averages here. Let's say I'm now in the negative and I have one that looks like this. I have a little position time that looks like this, okay? And I want to translate to a velocity time and a acceleration time. Okay, here I am at, let's just make up a number, negative 5 meters, and I'm going to 0 meters. Okay, so I'm going to draw another little meter line. Here's my 0. I'm out here at negative 5 meters and I'm going almost to 0. So that means I'm going east. That is positive velocity, and you can see that these slopes are positive. So first one done. So don't let this negative confuse you when you end up with you start in a negative position. Just means that you're on the left side of that 0 meter line. Okay? Now I need to determine if I'm speeding up or slowing down. Again, fast, fast, slow. So I am slowing down. And you're like, hey, all you have done is slowing down. What does speeding up look like? All right, well, let's start. If you were speeding up, then you would be going slow, and it would look like, well, we'll leave this, but over here, it would look like this. You would be starting off slow and then speeding up. So low, we would have almost at rest, getting faster, steeper, and then really fast. So then it would change these graphs, but I just wanted to show you what that would look like, because I just realized everything I did up here was slowing down. Okay, perfect. So let's do that. Now we have that we're slowing down because it's steep, not so steep, and then almost at rest. Positive velocity. So I need, if I'm slowing down, opposite signs on my acceleration. So that means my acceleration is going to be negative because velocity was positive. Opposite signs. Perfect. All right, now I'm positive velocity here. So I'm going to be in this section of the graph. That feels weird because you're like, but wait a minute, we had a negative position. Why am I not in a negative velocity? Because it's going east, and our negatives and positives are direction. So it's going to be positive velocity. I'm going to be in this section. And I'm going really fast, almost to rest. So it's going to look like this. Really fast up here at maybe 5 meters per second, going to almost rest, where it's that flat line. Again, now my acceleration, look, that's your acceleration. That is a negative slope, as it should be, and it looks like that. All right, that is your quick review on graphing and how the 3 steps in order to translate between position and time, velocity and time, and acceleration. Remember, when we talk about slopes on a position time, it's velocity. Slope on a velocity time is acceleration. Right now, we're talking about average. My colleague Beth will be talking about instantaneous velocity and instantaneous acceleration with those derivatives. So enjoy the next video with my colleague Beth, and thank you for watching, and happy physicsing.